Good evening. I'm Oliver Morton. I'm the Essays and Briefings Editor of The Economist, and I'm chairing this evening's debate about geoengineering. Panel discussion, probably better than debate, but don't let that hold you back if you want to turn it into a debate on geoengineering and trust. The historian of science, Simon Schaffer, in an essay commemorating the 350th anniversary of the Royal Society, gave a lovely definition of Promethean science, an experimental enterprise, vaulting ambition to safeguard humanity against a major threat, with the troubling hazards of following this science's recipes. I know of nothing that could better deserves the term Promethean science in the contemporary world than the science of geoengineering, which can be defined in many different ways, but let's say for the time being means intentional climate change, probably intended to, in some way, mitigate or offset the unintentional climate change that faces the world. We're having a conference about geoengineering, and particularly about forms of geoengineering that seek to reduce the incoming sunlight into the Earth system at the engineering department in Cambridge over today and tomorrow. And as part of that, we wanted to have a public event to discuss this one. Very happily, it turned out to be in the middle of Cambridge, or the beginning of Cambridge Science Week. And so to those of you from the conference, hello. To those of you not from the conference, hello. We're not going to be recapitulating what's actually said at the conference this evening. We're not here to talk primarily about aerosol particles and radiative forcings and all that good stuff, though some mention of that may be made. What we're talking about, and what I'm personally particularly interested in, is ways in which we can make the discussion of geoengineering, its vaulting ambitions and its particular hazards, sufficiently large to encompass the true nature of the challenge of climate change, whether it's intentional or unintentional. And to this purpose, we have a panel, one member of whom works actively in geoengineering, the other three members of which have been selected to give us real wisdom on the question of how you allocate trust in society, how you think about these sort of things, and where this debate might go from their own point of view. So I'm not going to tell you too much about them. I think you've probably got programs, but they are in order from the furthest to my right. Amartya Sen, winner of the Nobel Prize in Economics for his work on welfare economics, and particularly noted for his work on famine, which I think very interestingly, for those of us thinking about geoengineering, rescues from the popular imagination the idea of famine as simply a thing that the world does by not providing water and crops into something that's understood in terms of a system of both geophysical events and social events and importantly, social capabilities and empowerments. Onora O'Neill is the chair of the Equality and Human Rights Commission. She's one of Britain's most distinguished philosophers and particularly concentrates over her career on issues of trust, consent, and respect that we owe each other, and the autonomy that we should respect in each other, and thus couldn't be more appropriate to this discussion, even were she Martin Rees, who is sitting next to her, who is the former president of the Royal Society and the current Astronomer Royal, former Plumian professor here, one of Britain's most, I'm not even sure I need to say one, but a really terrific astrophysicist, and also now the head of Cambridge's rather spectacularly named Centre for the Study of Existential Risk. Also a character in a science fiction novel called Eater, should you ever want to avail yourself of that. He was president of the Royal Society when the Royal Society discussed these matters in a very influential report about 5 years ago, and talked about them as an area of science of great importance, but bedeviled by doubt and confusion and subject to excessive optimism. He's very good at understanding how science relates to the public, and I think that's part of what he'll be talking about tonight. But first, the panelist who is actually also a participant in the conference going on this week, which is David Keith. David Keith like Amartya indeed, is a professor at Harvard. He's a physicist by background, but since the 1990s he's participated in an extraordinarily wide range of activities aimed at understanding and possibly changing, both by geoengineering and other means, the Earth's climate system. And David will start off our discussions by saying a little bit about what geoengineering might be, and a little bit about his feelings about this issue of geoengineering and trust. So our first speaker, David Keith. I'm sorry, David. I'm very sorry, you can applaud him again. I should also mention, if you want to, thank you, if you want to enrich or relay the discussion we're having here by Twitter, please feel free to do so. The hashtag is SRMS15. It's being monitored, not in an invasive, scary GCHQ sort of way, but so that if you actually want to ask...
as well.
Well, yes, indeed. But if you want to ask a question by that means, it is possible that through clever technology, I may be able to see that question and even pose it. But for now, David, again.
Thank you very much. Oliver asked me to take a little longer and try and give you some general background, and I didn't know I was doing that until a few minutes ago, so I have some hand scratchings. But I'm going to actually start with really basic stuff about carbon and climate. A lot of you who know it can sleep through it, but this really is crucial, I think, for understanding the discussion to follow. So currently, about, on average, every one of us humans on this planet is responsible for the emission of about 5 or 6 tons of CO2 every year. Not remotely equal. I fly a lot and I'm wealthy. I'm probably responsible for 30 or 40 tons a year, and there are lots of people in the poorest billion who are responsible for more like 1/10 of a ton. But still, that's a sense of the total, and a ton is a kind of abstract thing, but think of each of us being responsible for the weight of 3 cars. It's hard to grasp this, but this is an enormous amount of material. The CO2 that goes invisibly up our smokestacks is the biggest, or maybe aside from mining overburden, the biggest material that humanity moves around anywhere. It's a huge amount of stuff. In the last many decades, emissions have been rising globally a little over 2% a year. And you can't see any evidence change in that since 1992, when there was a first kind of formal international agreement to restrain emissions to deal with the climate problem. The emissions are what we put into the atmosphere each year, but what most directly causes climate change is the concentration, the amount that has accumulated in the atmosphere, and that accumulation happens very slowly, so that the amount of CO2 in the air now has almost nothing to do with the emissions, say, in the last year, but in fact has to do with some sum of emissions over really the industrial history of humanity. So the concentrations, the thing that's driving climate change, are now about 25% higher than they were when I was born in 1963. They're about 50% higher than they were when James Watt invented the steam engine in the 1890s, improved, whatever. And that's worth thinking about because it was such an incredible example of feedback. What was the application of that engine? It was pumping water out of coal mines because you need to get the water out to dig more coal, and that you can't think of a better example of a chain reaction, good or bad. So climate change has all sorts of impacts, warming being only one of them. And I won't say much more about the impacts, but the impacts are sort of proportional to this total amount of carbon. That's true whether you're thinking about melting the big ice sheets that, you know, if we did nothing to change things over the next many centuries would materially change the coastlines of the planet. Or much nearer at hand, high temperatures during the germination period of many of the important food crops can significantly reduce their productivity, and there's some evidence that there's already enough warming that we're seeing impacts on global food crops of order 5%, although that's masked by the steady increase in productivity of crops because of better inputs, etc. So in the long run, if we collectively, and collective action is the whole crux of this problem in many ways. If we want to get out of the risk of climate change, we have to stop putting CO2 in the atmosphere, at least in the net. And nothing I'm going to say about solar geoengineering changes that. It only changes it with respect to time scale and with respect to what the near-term risks are. So what is solar geoengineering? It is the idea that we might deliberately engineer an increase in the Earth's overall reflectivity. So there's reflective because clouds, for example, reflect some sunlight back to space. And so we might arrange to increase the Earth's reflectivity, and this would partially and imperfectly and temporarily reduce climate impacts that we care about. And actually I already overstated because I said would, and I really should have said probably will or some of them. So how would we do this? First of all, we'll talk about how well it would work in a second, but how would we do it? In some sense, it's kind of horrifyingly easy to do it. So the way I've thought about the most involves putting sulfuric acid, basically an air pollutant, in the stratosphere where it would reflect away a little bit of sunlight. Why sulfuric acid? Actually, a droplet of water in the stratosphere reflects sunlight fine, really almost as well as a droplet of sulfuric acid, but it would evaporate essentially instantly. The stratosphere is very dry. So if you want to keep water droplets there, you need something to hold the water molecules from evaporating, and that's what the sulfuric acid is there for. There are lots of other things. We're investigating diamond and alumina and other things that might or might not be better, but that's one example. Another idea is to use sea salt sprays to increase the reflectivity of some kinds of marine stratus, the kind of low-lying clouds. The details of these things really aren't our subject here, but the point is increasing the reflectivity could almost certainly partially offset the climate risk. One of the central scientific questions is how much? So turning down the sun, if you'll let me go from sort of specifics to imagining we have some knob to turn on the sun, there's a lot of trickery in between those two things in many ways. Turning down the sun is not anti-CO2. So carbon dioxide has many effects actually beyond just climate. For example, geochemically, it changes the earth in all sorts of ways, making plants grow a little faster and use a little less moisture, for example, some plants more than others, making the ocean more acidic. We're already committed, I think, to see many less coral reefs in the next century than we have now. So CO2 has lots of effects, and just turning down the sun surely is not anti-CO2 and does not make those effects go away. But it does a better job than a lot of us expected. So if you warm up the planet with CO2, and then at least this is true based on models, but the models are themselves based on enormous centuries of science and of experiments. The models aren't just things people cooked out of their back pocket yesterday. If you, in a model, turn up the amount of CO2 and then correct back, say, surface temperatures or the amount of precipitation using one of these turning down the sun methods on a region-by-region basis for many variables, not just temperature, but also precipitation, also extremes of precipitation, also sea ice, it looks like these technologies could substantially reduce the change in climate, and so therefore many of the climate risks. And that is, in a sense, kind of drum roll, that's an extraordinary possibility, because there are risks to some of the most vulnerable in the world and to ecosystems that will occur over my lifetime or my kids' lifetime, and the fact that we have an opportunity to reduce those is pretty substantial. And here I need to circle back to where I was before. I said an opportunity to reduce. So the whole point of my distinction between the amount of CO2 we emit each year and the accumulation in the atmosphere, the whole point of me making that distinction is when you cut emissions, even if you cut emissions to zero, to a good approximation, at least over 1 or 2 human lifetimes, all you do is stop making the problem worse. That's a very big deal. We'd like to stop making the problem worse. But when we stop emissions, we stop adding more CO2 to the system. But the CO2 that's there more or less stays. And the temperature response doesn't change very much if we stop putting more CO2 in. So that's not true in the very long run. In thousands of years, we of course do make the problem better. But in the short run, it is true. And that is one of the central reasons that it's so politically hard to get a deal here. I believe we can get back to that. So that's what solar geoengineering is. A couple more words before I stop. One is that we often talk about this as science. Indeed, the name of this conference is, the conference that some of us are at, is the SRM Science Conference. In some ways, it's a wonderful conference. That's a misnomer. This isn't science in the sense of trying to understand the feeding behavior of polar bears or the behavior of neutron stars, where we're trying to discover facts about nature. This is really the creative application of science and generation of new science and knowledge to an end, to a goal, and that goal is necessarily human determined, and different humans will have different goals. Values enter in an essential way. So it's not science in kind of important ways. It would be nonsense to say that Stephen Jobs discovered the iPod, right? He used existing money and technology and knowledge to assemble this thing that fit a need. He also helped to create that need, because a lot of us didn't know we needed these little cell phones until he did that, shaped our need and thereby shaped the society. But it's not really right to think he just discovered it. And in the same sense, in thinking about the future of solar geoengineering, you really think about it wrong if you imagine that there is this thing called solar geoengineering and we can do more science to figure out how well it works. And yet, I think, without getting into a big debate, many of my colleagues still kind of look at it that way. And I think the crucial thing is that in fact we have to figure out, and there's no single we here, there are many different actors with different opinions, including lots who think we shouldn't do this at all, how we might do it. And how we might do it to reduce risks. But there are different risks, and people care about them differently, so there's no one right optimal way to do it. To give you one hint of how we might do it differently, one of the particular risks that many of us, including me and a research group I've come out of, are very deeply concerned about is that putting sulfates in the stratosphere could help to reduce the amount of ozone there, to further destroy the ozone layer. This is actually building on a previous insult that humans already did, because the reason the ozone layer is damaged is because of chlorine that came up there from chlorofluorocarbons that we emitted. They were nice refrigerants. They were, in turn, better than the old refrigerant called ammonia. It used to kill people, and here you see once again that technologies are always fixing previous technical fixes. That's just what technology is. So sulfur can destroy ozone because of that existing chlorine, and so in my with my tech fixer's hat on, me and several people, including some in the audience, are thinking about ways that we could get around that problem by using something else, alumina or diamonds, or we have ideas for coatings for these particles that in some of our models actually make the chlorine impact go away completely, so we end up with more ozone with geoengineering than when we started. But you can be sure that any way we do that will have its own problems and uncertainties. There's no such thing as a magic certain free lunch with a thing like this. To give you a specific suggestion for how we might actually do this. So far I've tried to give you a sense of sort of the little bit of a sense of the field as a whole. We might say in 2020, start to do this in a way where we gradually increase the amount of solar geoengineering we were doing, and did that just so that we cut the rate of growth of what the climate science community calls radiative forcing, more or less how hard we're pushing the climate with all that CO2 and other stuff we're doing. Cut that rate of growth in half. That's a specific thing we could do that is in some sense moderate. And if we did that for 50 years, the amount of sulfur that we were putting in the stratosphere 50 years from now would still be of order 5 times less than the amount put in by a single volcano, the Pinatubo volcano. And that gives us a lot of confidence that the unknown unknowns probably aren't too awful, because we observed Pinatubo with some accuracy, and we're talking about a lot smaller perturbation than that. But there's some overstatement there a little bit. So that's a specific example. One last connection. Another thing that's often called geoengineering, there's 2 very distinct things called geoengineering. One is solar geoengineering, what I've been telling you about. Another thing is the potential for accelerating carbon sinks or otherwise removing carbon from the atmosphere. And one of the ways that we could get out of a long-run commitment to do solar geoengineering is to accelerate the removal of CO2 from the atmosphere. And there's a host of ways we might do that, all of which have their own costs and risks. But that gives you a pathway to, I think, a potential, not solution. There's no solution for something as complicated and multidimensional as climate change, but a pathway to a softer landing that brings us back to something a lot more like a pre-industrial climate in, say, 2 human lifetimes in a way that's tractable. And I think one of the attractions here is that's a fundamentally more attractive proposition than the basic proposition that I and lots of other climate scientists offer the world, which is spend a whole lot of money, work like hell, and stop making the problem worse. You kind of lose more slowly. So I think there are optimistic visions here. This geoengineering is often perceived as sort of a bad idea whose time has come. I think that's kind of a too easy a thing to say. Eli Kintish, a journalist, said that. It's easy to say, it sounds good, but I actually really don't think that's true. I think that this is a powerful idea, and like any idea, it could be used for good or bad, but there are ways we could use it that could really get to a much more positive, environmentally and socially positive outcome, but only if we can arrange ways to collaborate on a single planet, because the cheapness of these technologies, and I think I'll close there, mean that it's potential for almost any country, even quite poor countries, could potentially employ these technologies in a way that changed the whole planet. To give you a sense of the monies involved, we've done quite careful engineering studies of what it might cost to loft materials in the stratosphere. It's fun, kind of geeky stuff. But the costs are of order of $1 billion a year, just for the raw capability to do it. Not to monitor it, which probably costs more, not to think hard about it, but just kind of the raw capability to do it is of that order. Say kind of 30, 40 aircraft that are a small fleet of modified business jets. And that's a stunningly small amount of money. The costs of climate change in terms of the impacts, adding up all of them as economists try to do with lots of uncertainties, are reckoned of order $1 trillion or more a year, and the cost of cutting emissions are reckoned of order $1 trillion a year. So $1 billion is tiny. So if you think about cost benefit, you say that's great, but I think that's really not the right way to think about it. The right way to think about it is that money isn't the issue. The issue is there's risks of doing it, and there's risks of not doing it. There's a complicated kind of risk-to-risk calculation, but that's still framed as if you're sort of a single unitary optimizer, but that's not remotely how the world is. It's got 7 or so billion people who will have different opinions, and there also is the natural world who's I think counts in some way separately from just the sum of humans' value of it. So that attempt to give an overall summary?
Very fine. Thank you very much indeed, David. And next we'll have Martin.
Thank you, Oliver. So I'm really going to provide what's called unspecific wisdom, which means I'm nothing like an expert on this subject. But I would like to say something about putting it in the context of climate change policy generally. Of course, the one thing we all know, and is uncontroversial, is that CO2 is building up in the atmosphere. In the usual units, it was 280 parts per million. At the start of the industrial age, it's now about 400, and it's rising, and people are trying to keep it below 450. And we know from simple physics that carbon alone, if the concentration doubled, would raise the mean global temperature by 1.2 degrees. That may not seem very much, but there are 2 provisos. The first is that there are other feedback effects, so that as you raise the amount of carbon dioxide, you raise the amount of water vapor, etc. And there's an important number called the climate sensitivity, which determines how much the temperature actually rises for each extra bit of CO2 you put in, which is not very well known. The other point is that the headline figure that everyone quotes of the mean temperature rise is just an indicator of global change in weather patterns, where the temperature rises more over the land, more in some places than others, and the places where you get rainfall and drought move around. So clearly we are threatened by major changes in climate and an overall average warming. But the main concern is changes in the global weather patterns. Now, this is, of course, what is motivating all the efforts and the conferences, next one coming up in Paris, to control the amount of CO2 emitted. And this is going to be very hard, of course, because we know our dependence on fossil fuels. And I personally think it's rather unlikely that very much will be done to reduce annual CO2 emissions anytime in the next 20 years. They may even go up. And that therefore means that 20 years from now, we'll probably be in the danger zone. As a proviso, there are, I think, three things that probably should be emphasized in efforts to control the rise of CO2. One is to perhaps emphasize energy saving, because obviously if we can cut down the consumption of energy by insulating buildings better, etc., then that is good for everyone. It saves money and saves energy. So a big focus on energy saving is important. The second thing we can do is to focus not just on CO2, but on other gases which make subsidiary contributions to global warming, such as methane, and also black carbon, effect of soot on the climate. And a blitz to cut down on those is probably more politically acceptable. That's because not only will they have a diffuse global effect, but they'll also have a local benefit. In China, for instance, there'll be a huge benefit in clearing up pollution, and that gives an extra motivation for doing something. Because the main problem, of course, with the general effort to cut CO2 emissions is that the benefit is not local, it's global, and it's long-term. So it's hard to motivate action. But on the minor constituents, there's a local, shorter-term benefit. And the third thing, which I'm sure we should be doing, is increasing research and development so as to make a quicker transition to a dependence on non-carbon fuels, solar energy and things like that. They'll come at some stage, but if we can accelerate the move towards a time when these are more economical, then that would clearly help. And I personally think that in this country and others, we do a lot better to increase the R&D budget for energy by a large factor, bring it closer to the health budget, health research budget, and perhaps spend more money on that and less on subsidizing wind farms, and that would be the same as far as the public sector is concerned, but it would be more effective. So those are the three things we should do. Now, what will actually happen? I suspect not very much. I suspect the CO2 concentrations will keep on going up at a perhaps accelerating rate for the next 20 years. And in 20 years' time, we will know a great deal more about the sensitivity factor. We will know how much the temperature rises for each extra bit of CO2. And then there are two options. It could be that the optimists are right and there isn't very much amplification and that the temperature would only rise by 1.2 degrees if the CO2 doubled. But it's more likely that the temperature will rise a factor 3 more than that. We don't know. But 20 years from now, we will know. And if it is clear by then that we are on a steeply rising trajectory, where the temperature is getting into the danger zone, heading towards 4 degrees rise by the end of a century, and if it's clear also that the regional effects are serious, then there may be strong political pressure for a plan B, namely geoengineering, as a way of at least buying time so that the temperature won't keep on rising even if we continue to put out CO2. And I think that is the context where there's going to be a real big public debate on the case for having geoengineering. Obviously, it would be better if we could segue towards a low-carbon future without any debate of this kind, but as I say, I think it's rather unlikely. Now, as David has said, geoengineering is feasible, it's fairly cheap. And, of course, the worry is it is so distressingly cheap, as he said, it could be done by one nation, even by a corporation. And so it's going to be very hard to ensure that if it is done, it is done in a responsible way. And the problem, of course, is that in order to be confident of the consequence of large-scale geoengineering, one has to have climate models much, much better than the ones we have now. The ones we have now are not very good at forecasting what the regional effects will be of the general global warming. And we need even better models still to be confident about what the effect would be in different parts of the world if we tinker with the climate in these new ways. And it's going to help some people, and the effects in other parts of the world may be deleterious. And that is why it is going to be so controversial, because to put it at a slightly frivolous level, if countries can blame each other for the weather and the climate, then the only beneficiaries are going to be the lawyers, because it will be a bonanza if you can have litigation about changes in the weather, or maybe even international disputes of a more serious kind. So that is a sort of worry that would be inevitable if one does engage in large-scale geoengineering. And, of course, different countries would want to turn down the thermostat by different amounts. David says that we should try and just stabilize things, but we don't know that there will agreement. Some people, if they knew it was possible to change the climate by geoengineering, might want to do more drastic things, and there'd be big disagreements between different countries in what was done. And for that reason, I think we should hope that we can indeed deal with climate change by reducing CO2 in the way that's being attempted, although that is very hard. And of course, again, as David mentioned, even if we do bring down the temperature by putting stuff in the upper atmosphere, then this will not eliminate the other deleterious effects of enhanced CO2 concentrations, particularly ocean acidification. So it's just buying time, and we've got to keep on doing something about that and hope that nonetheless we can eventually reduce CO2 emissions. So I think it would be really bad news if we ever do have to take seriously geoengineering. But nonetheless, having said that, I'm strongly in favour of research at this present stage into geoengineering, because we want to know which ideas work and which don't work. We've got to have a feel for which would be the best techniques, as David was saying, and we want to do computer modelling so we know what the effects would be of changing the climate in particular ways. So I think it's absurd to say that because we hope never to have to use these techniques, we shouldn't research them, because if nothing else, the research may lead us to believe that it is indeed very unlikely that these will be acceptable. So I'm very much in favour of research into the techniques that will be used to insert stuff into the upper atmosphere, put stuff in the oceans to soak up CO2 and all these kinds of things. So let's study this. It's great as a conference going on now to do this, but let's hope that 20 years from now we have succeeded in either controlling the annual emissions of CO2 so they're going down, or that we've by then develops clean energy so that a transition to clean energy is going to happen then before the CO2 gets really into the danger zone. Thank you.
Thank you, Martin. Onora, please.
Thank you. I'm going to talk about trust because if this goes ahead, we're going to have, and perhaps even if it doesn't go ahead, we're going to have a most complicated international, multi-generational debate. This affects everybody, after all. And what I'm going to say at this point is that I think there are two completely distinct ways in which we talk about trust. One of them is rather popular, but of minimal relevance to decisions about science or science policy or geoengineering. The other is rather neglected, but I think highly relevant to those discussions. So let me start with the popular way of discussing trust. The popular way of discussing it, of course, begins with an assertion that there's a crisis of trust. That's actually not very well empirically grounded because if it's based upon looking generally at the results of opinion polls repeated across time to see whether levels of trust are going up or down. Generally, and this surprises people, but it appears to be the case, where you have an adequate time series, maybe 20 years, it's pretty static. That's to say, 20 years ago in the UK, and other countries are not that much different, it was the doctors and judges and nurses who were most trusted, and they still are. And 20 years ago, it was the politicians and the journalists who were least trusted, and they still are. Nothing new. So opinion polls seem to be a rather unreliable evidence base for the claim that there is a new growing crisis of trust. And I think that it's perhaps more useful to think about the sort of evidence that we do get from opinion polls. What opinion polls sample are generic attitudes. So somebody comes up to you and says, "Do you trust teachers?" Well, you may think, some of them, but not others. To do some things, but not other things. And that would be perfectly sensible, but that's not what the pollster asks you. The pollster asks you, do you trust teachers? On a scale of 1 to 5, how much do you trust them? And amazingly, a lot of us are quite willing to choose a number between 1 and 5 then. And that is what the opinion pollster gets, and then, of course, averaging it across respondents, you get a figure that says that GPs are highly trusted, but scientists, by the way, who work for universities are quite highly trusted. Scientists who work for companies are a bit less trusted, but still relatively high. Now, what is being sampled by these questions? I think when one reflects upon it, it is generic attitudes. I say generic because it is not differentiated. The fact that the person who was polling asked you, how much do you trust doctors, or how much do you trust teachers, means that you can't say, for this purpose quite highly, for other purposes not at all, or for this one rather highly and others not at all. And as a matter of fact, when it comes to journalists and politicians, there are those we trust rather highly, although we might not trust the generality of journalists and politicians very highly. And equally, when it comes to nurses, there may be some whom we don't trust one bit at all, but perhaps for rather good reasons. Think about things that happen in mid-Staffordshire. So these generic attitudes aren't going to give us a very useful input to practical debates about trust. Now let me turn to the practical question. We'll forget about generic attitudes. What one actually wants to do as a matter of a practical matter is to work out in whom to place trust and in whom to refuse trust for specific purposes. It's not useful to know about the generic attitudes. What's useful is to have the evidence of who's trustworthy and who's less trustworthy in specific matters. So that when we're looking at the practical question, whom should I trust in these matters? What we want is the evidence of trustworthiness or lack of trustworthiness. The point, after all, is not to get more trust, though it's often said to be the point of the matter. The point is to get better placed trust. Think of somebody rather untrustworthy, like the very aptly named Mr. Madoff, who made off with a lot of people's money with a Ponzi scheme. Should there have been more trust in Mr. Madoff? No, that would have been even worse. But so it's quite a different question. It's a practical question, but it's also an epistemological question. Because what you want to find out about in placing and refusing trust is how trustworthy the other party is in particular matters. I think there are generally 3 things that we want to be able to judge, namely their competence, their honesty, and their reliability. And I won't go through why reliability is an additional one. So judging competence, honesty, and reliability is quite feasible for most of us day to day. You will trust the person in the corner store to be selling fresh milk because you've often bought a bottle of milk there, and it was reliably and fresh milk, and it was competent sales, and it was honestly honest dealing with the financial aspect. But it gets hard when it's complex things like science. But it's the same questions we need to be able to answer. And public debate, in my view, needs to concentrate on making it feasible for all of us to judge the competence, honesty, and reliability of particular technologies. Now, there are ways of doing that, and it's not, as it were, all effort by the scientists and none by the others. It has to be effort by all parties and genuine communication. But I don't think it is impossible, providing we don't set out with the illusion that opinion polls will help us. Now, why are opinion polls so popular? I suggest they're popular for two reasons. If you are in the business of selling something, you really do want to know, and the word is used all the time, about your reputation. You want to know whether you are trusted. You may or may not care about being trustworthy, but you want to know whether you're trusted. And an opinion poll is useful for finding out that. So people in marketing, opinion polls have their point. The other place where they have their point is if you want to be elected. You want to know how many people are going to vote for your party or this candidate or that candidate. Opinion polls are quite useful. But these are limited purposes, and we shouldn't use the wrong methods in order to judge when and why and for what reasons we're going to place or refuse trust in particular technologies for something as important as mitigating or indeed reversing the factors that are leading to climate change.
Thank you very much indeed. And our last panelist.
It's a very difficult subject, I have to say. I think the two issues I'm be concerned with. One is the issue of trust that relates to the issue of democracy also, which I'm going to discuss. And the other is the issue of the penalty of getting things wrong. I think one of the things that economics teaches you, is not a very flattering thing for economics, is that how you could have an excellent argument, very convincing argument for one kind of expectation, and find out that things have worked out to be completely differently. And that's a very important lesson to learn, because, and it's not a fault of necessarily the discipline. There's so many factors, and 127 factors you're playing with, and you have taken into account 106, and it turns out that one of the ones you haven't really is actually tremendously important. I think that's let me begin with that. I'll come to the trust and democracy later. I think the danger of any kind of geoengineering of the kind that we are discussing is that it may not be perceived as clearly as when you describe it on paper. And then it turns out to be quite different. And what, in the context of a related subject, climatic dangers, people like Marty Weitzman and others have talked about the fat tail, that there is a low probability of absolute disaster. And I'm afraid some of the ones really make me tremendously nervous about the future of the world. If I have a strong reason to endorse that Martin is right in hoping that Plan A might prevail and Plan B may not be needed, it's partly because Plan B has kind of scenario which would be really extraordinarily difficult. Now, Plan A could have that too, and indeed the fat tail discussion is really about what happens if you don't succeed in doing anything and the climate gets worse in a big way. But I think the idea of doing any of these things with some idea, some ability to calculate the probability of various outcomes, I think that that's a really worrying question. There was an economist called Frank Knight who was very keen on contrasting what he called uncertainty and what he called risk. Risk is when you have expected utility, you can have probabilities that are known. I think that's a really philosophically, foundationally weak reasoning, for reason that was known to Bernoulli also, that these uncertainties and these probabilities are really in some ways expectations in your mind that you have formed. They're not based on frequency, because even if they are based on frequency, you translate that frequency into some expectations in your mind. So we are dealing with a very difficult territory where the penalty of things going wrong could be extraordinarily large. And of course, things may well go right, in which case everything will be fine. But we can't begin to talk about these without taking very serious interest in the wrong, the unexpected, or the disastrous scenario. And we have had a lot of experiences of that, even in other areas. I think I must, as an economist, claim that very few non-financial economists wanted Europe to have austerity as a plan. I think very few did. Lots of the financial economists certainly did. And the results have turned out to be very, very different from what was expected by the European Central Bank and all the others. And the psychology is a complicated thing. If something hurts, which austerity certainly did, a lot of people are inclined to think that it must be doing some good. Otherwise, that's the characteristic of hurting. And I think Bernard Shaw said somewhere, I think Man and Superman, which is I think on now, about an Englishman often feels moral when he is merely uncomfortable. I think there is a little danger that here, that it may look that there are things happening that one, my God, wouldn't be expect when we are doing really extraordinary things, wouldn't be expect that. Now, of course, I don't want to press the analogy with what happened to the Eurozone. Now, of course, the authors themselves are revising. And there the question of trust comes into that. We trusted just too much. But you see, I think I would like to extend Onora's discussion further. It's not only the question of whom can you trust, who are the reliable people, and so on. I think it's a question of democracy also. I don't think Europe would... I'm sorry to go on having this analogy because we have a disaster at hand, and if you're discussing a disaster possibility, it's not a bad idea to look at disaster at hand. One of the reasons that it went wrong is that no one was allowed to actually have a debate about it outside the financial circle. It was the small group of people, the European Central Bank, the Bundesbank, the Netherlands Central Bank, who determined, and with a little voice of Bank of England and so on, though it was not directly involved in the Eurozone, a policy was adopted. And there wasn't public discussion, which could have pointed out many different things. Somehow it was also thought earlier when the euro, the unified currency was brought in, people were crazy enough to think that that would somehow be a first step towards European integration. Whereas I think any kind of reasoning would have allowed the possibility, which indeed has turned out to be the case, that when you constrain an economy in a situation when it cannot get out of a crisis by devaluation, which is what Euro managed to do, then you would have a problem. When my friend, and I've had very few rich friends, but I have one or two, one of them being George Soros, when he was betting against Britain, what was he betting against? That Britain would not be able to manage without devaluation. And of course he got the devaluation, made his many, many billions. On the other hand, that possibility isn't, of course, open now to Greece or any other country. Now, these are easy to expect, but if there had been public debate, I think these would have come up. There wasn't. And now I gather from New York Times this morning, Greeks can't tolerate the sight of Germans, and Germans don't like the Greeks at all. This is not a very good way of getting the European Union furthered. I think the expectation can go terribly wrong if you don't have enough public debate. So in some ways, I'm on the same side, and concluding with Martin and with Onora, with Martin, in the sense that I would like the scientific things to go on. But I would say one of the reasons is that until the scientific things are done, there is a kind of effect of a false hope that something could be done which is not so dangerous. More we know the details, more it is possible for us to find out how things can go wrong in these things. And so some basic thing that if we don't do the emission control now, if we don't do the subsidy, on which I'm very keen, on solar energy, massive on the public level, particularly on storage, which could make a dramatic change in the world. And the more numb we remained about the danger of nuclear energy, which I must say very wise very much, especially not just the Fukushima and what happened, but just the recognition that a explosive on one of the many nuclear plants in India, just a normal bomb, had a certain probability of producing a nuclear catastrophe around there. Not certainty, but it can. And it may require more organization than went into the destruction that happened in the Taj Mahal Hotel. So with the terrorism, with the possibility of sabotage, the nuclear test, I mean, that's enormous problem. On the other hand, the total amount of government money that has gone into subsidizing storage, and that's really where, in a sense, as I understand it, the bottleneck is actually minuscule in comparison with what's needed. So I would, if this kind of experiment absorbs a lot of money and cuts out kind of research under Plan A star that we do want, I would be worried. But I gather from what they've said that it's not that expensive, and so maybe it's fine. But I think that's what I would like to do, and I would like not to trust anyone, but to have actually public discussion of it. It's not just in some ways, we all worship at the feet of John Stuart Mill. It's his things about liberty and democracy, rather than his representative government and 2 votes for the university-educated people, and so on. It's the public discussion that I would like to have, and we have suffered from it here. Having just got back from India, the lack of public discussion on so many major issues, we're paying a huge penalty for that. I'll stop there.
Well, thank you all very much indeed. Having just heard the glories of discussion and democracy extolled, let's get to it. I'm kind of assuming that there are people with microphones in the hall. Yes, there they are. One blue, one yellow. So now I know where microphones are. I need to know where to direct them, so I need to look out for hands. Gentleman there. Yep. No, I was actually pointing at this gentleman here. Hello? Yeah? Okay, blue microphone. Could it go to that gentleman with his hand up there, please? There we go. That was what I was looking for.
Right, I'm John Nissen. I'm from the...
Could we get a little bit more volume? Okay.
Hello. Is that working? Yep. Okay, I'm John Nissen. I'm from the Arctic Methane Emergency Group. And Martin Rees mentioned that we have to look for regional effects, and we have to wait 20 years before we're sure that we've got a regional effect which is sufficiently serious to worry about. I think we've got a very, very serious regional effect already, and it's the wandering of the polar vortex, the jet streams and so on, is causing a lot of climate change, and things look as if they're going to get a lot worse if the Arctic continues warming. Isn't this actually now the time to introduce our plan B, because our plan A has not worked?
Martin, I think that's a question directly to you, so
okay.
I'll take that.
Well, I agree that the changes, especially in the Arctic ice, do seem to be secular changes. But my worry is that we certainly wouldn't know now what to do in order to affect the polar jet stream or the polar vortex. I don't think we know what to do yet. We've got to wait. But if I can just make another point about all these arguments, we all know that even though there are changes now, we worry more about the changes in the future. In one generation and even more. We worry, as Amartya said, about the low probability of something really catastrophic. And that's what we want to guard against. And here, it does bring in ethics, because if you apply the standard discount rate, then you don't care about what happens more than 50 years ahead. You write it all off. Whereas if you do what is more ethical, surely, and value the welfare of the next generation as much as ours, don't discriminate on grounds of date of birth, then you should be prepared to make some sacrifice now in order to remove a possible risk of catastrophe from people 50 or 100 years from now. And that's the reason which I think underlies the case for doing something now. And of course, it's at least clear that there are some trends, like in the Arctic, which are the sort of canary in the mine, as it were. And it's good that we should notice those.
David, I think you wanted to come in on that too.
Yeah, this Plan A, Plan B story, I think, often posits that we might keep going with Plan A until somehow we find out the climate is much more sensitive to CO2 than we thought, or we somehow realize we're failing Plan A and then do Plan B as an emergency measure. And I want to argue that's a very questionable framing. I think the way we're most likely to make bad decisions about these solar geoengineering technologies is precisely if we did it in a big rush in an emergency. So the kind of idea that there's a big red button and you turn it on at massive scale is possible, but I really want to argue against that. That if you ever want to do it, there are profound reasons you might want to start very slowly, because you don't want to perturb the climate very rapidly. If you start slowly, you begin to get some modest benefits of slowing climate change from doing it. You begin to learn about how to do it, both technically and politically, and you begin to be sensitive to some risks and some unknown unknowns that are exactly what you want, so you gain some knowledge. And so I think I want to push us away from this kind of Plan A, Plan B framing. It's a mixture of things we need to do. It could be we don't ever want to do this solar geoengineering, but not because we're holding it as Plan B, just because we decide not to.
The yellow microphone has got to someone who deserves it, so up there, please.
Thank you. Wow, that's loud. I'm Jack Stilgo from UCL. I'd like to particularly ask about this notion of geoengineering being cheap, which I think is a very interesting one, and immediately makes me remember that in the 1950s, in a sort of flush of technological enthusiasm, Lewis Strauss said that nuclear power would give us energy too cheap to meter. And it turns out that when you account for all of the complexities of technological systems, it looked rather expensive. So I just wondered whether we could just sort of run a thought experiment, which was just to ask, what if geoengineering wasn't cheap? What if it wasn't easy? What if it turned out to be extremely hard indeed?
Did you want to ask that to anyone in particular, Jack, or?
I think David in particular, but I'd be interested in the thoughts of the others.
The Lewis Strauss one is really easy to say, but I think the answer is that's it. There were lots of other people who realized at the time, if you go back and read, that building full energy systems, which included steam turbines and all the stuff you need in a nuclear reactor, would not be too cheap to meter. And so at some level, you're cherry picking. And the answer is we do know some things about science, some basic things about ratios of things and amount of matter that do say something about long-run costs. So it's completely plausible that it would cost 10x what I'm saying, but of course, even if it costs 100x what I'm saying, it's still something that's relatively cheap compared to other things we'll do, which isn't, again, a justification for doing it, but it's a statement that cost does not seem to be the primary driver.
Okay, had a question there, and then, no, there please, yes. Yeah, that's going in the right way.
My name is Terry Lawton, I'm from Wexford Skywatch. This question is for David. What would you say to the 31,000 American scientists who believe that global warming is a hoax?
Okay.
I'm not aware that there are 30,000 real scientists who are thoughtful in the sense of, scientist isn't just a label you get. It means an attitude of mind. It means being serious about uncertainty. It means being honest about the facts. And I'm not aware of any people who have the kind of core geophysical knowledge, who actually have their arms, sleeves wrapped up and are working on this topic. And I'm not aware of one who thinks it's a hoax. So I have spent lots of time with Richard Lindzen, one of the most prominent skeptics. He definitely doesn't share my view about the likely impacts, but he doesn't think it's a hoax, and he's probably the most prominent such person.
Okay, yellow mic, please. We'll come back. Can you give the mic back? But yellow mic, please.
Hello, thank you very much for a fantastic panel. Chris Hoy, Overseas Development Institute. So my question was particularly for Professor Sen. There's a lot of talk about the costs of climate change and the costs of action, but I guess it would be great if you could talk about the distribution of those costs. So it appears as though poor people are going to be suffering the most from climate change and have the least capacity to be able to flip the bill to do anything about it, even if it is $1 billion. And it would be great if you could speak more about the distributional aspects. Thank you.
I'm not sure I actually heard that very clearly. I'm supposed to wear a hearing aid, and I was given one. And
distributional aspects.
Yeah, no, that bit is the only word I got. But I did wear it one day, but I went to Trinity High Table, and I could hear everyone's conversation, and I felt so ashamed of eavesdropping on everyone that I took it off and hadn't put it back again. But I think the distributional aspects are important, and I think many cases that may have a complex bearing on that, because even if you look if you think of Plan A, Plan B, and I'm going to comment on David's skepticism of that, but Plan 0 of not doing anything, we know that the inequality would be large. It would be bigger for Maldives and Bangladesh than for many other countries. So I think that's going to be major, and I'm delighted that you raised that question, because the idea of thinking of the Earth as one, population, global population as one thing, is I think, of course, a mistake. That the risk that we take could be much more dangerous for one group than for others, and the risk for not doing anything could be also similarly. So I would just salute the question, but not try to provide an answer, because I don't know that we can find a general answer, other than what you're suggesting, namely, keep your eyes on the distributional side and not be too mesmerized by just aggregate numbers. And if that's the message, I very much agree with that. If I may take this opportunity to comment on David's thing, I think 2 points there really. On the cost question, 10x, 100x, I think what the questioner was asking, it may have many implications. It does have implications on my point, for example, namely the amount of money that's available for storage on, research on storage and investment on storage may well be affected if this costs a lot. So I think there is that issue. The other thing is that you said yourself, David, that cost is not the main thing, but the risk. But the idea that starting slowly, we have a kind of model in our mind of a continuity, and continuity where you things do small and it goes slowly up. Many of these processes are not like that. They have huge discontinuities. And tiny amount of smallpox somewhere could generate a fantastically disastrous result. We don't fully know many of these things. You scatter something in the atmosphere, what the result of that would be. So that the constellation or the certainty and the confidence that we get, we are doing things only in a small scale, assumes a model of continuity, which I think epistemologically I find it difficult to accept.
I think we can. Do you want to come back on that?
Very briefly, many of the examples that people use for discontinuity, as you did, involve biological systems.
No, I agree.
So smallpox is really different because it reproduces.
No, I know.
And there's lots we don't know about sulfur.
You want me to give another
but it doesn't
example
have sex.
of a landslide? Shall I give you one, which is not a biological example?
Understood, but
Tiny bit.
sure. We agree there's big uncertainty. We agree that even if the Earth system is pushed gently, which we're doing, or we can argue smoothly, that there will be unexpected and stochastic outputs. We see that already. But we are in lots of ways, including sulfur in the lower atmosphere, which kills millions of us each year, already pushing the climate in ways that are gradual.
We've got a question down there. I should remind you all, by the way, you can also pose questions, though I don't promise that I'll get to them, on Twitter, which is #SRMS15. And should I not get to them, you will at least have the advantage that all the other people following on Twitter will be able to converse with you. Anyway, question down here.
Thanks. My name's Duncan McLaren. With one of my hats on, I research the justice implications of geoengineering. And I'm interested in following on from discontinuities about discontinuities in the social sense.
Yeah.
What do members of the panel think would be the effects on climate policy, mitigation policy, if researchers and scientists took SRM geoengineering much more seriously and started promoting it? In particular, what do you think the governments gathering in Paris would do? Would they suddenly come out with a better mitigation plan, or do you think they would put off action even longer?
Oh, no, actually, I'd be very interested in what you had to say about that, but also I think I cut you off. You had something to say on the previous question.
Yeah, and I would like to also to respond to that question.
I think we have to be pretty pessimistic about international agreement. So I wouldn't put my money on getting agreement that is actually followed up. I still think it's worth having the conversations that might lead to agreement for the sort of reasons that Amartya pointed to, in that if people aren't beginning to share a view of the problem, I think that it will be extraordinarily difficult to get any degree of consensus. But I'm a bit more pessimistic in that I think we may face a situation where sometimes verbal agreement is possible and an international agreement is possible. But as with other technologies, as with other things, we see that action is not followed up. So I think that's the realistic context in which to address this, not expecting an agreement that resolves it, which takes us back to the point David made, that there could be unilateral action. In a sense, that is one of the quid pro quos of a technology or some technologies being cheap. But I think there's another economic question that we have to address as well, which is how many other lines of research bear on the issue of addressing climate change. Yes, geoengineering, and in particular increasing the reflectivity of parts of the Earth's surface is one and is cheap. But there may be many, many others, and I would point to fields like agronomy and botany as possibly also deserving a great deal of investment, so that we understand what photosynthesis really can and cannot do by way of carbon sequestration, for example.
Amartya, did you want to?
No, I totally agree with that. I'll just say that it's not that any particular fear that my knowledge is not enough to indicate that this is really the main fear. I just don't know. But I mean, when you're playing around with something as fundamental as the issue that I hear. One would be concerned about the catastrophic results, which may have a low probability, like the fat tail thing, and the distributional question that somebody raised. And it could be tremendously, it could have a tremendously harmful effect on some people compared with others. I'm saying that not because I know that that will happen. If that were the case, I wouldn't call it uncertainty. I'm saying that because these are things that I would like to be much more discussed, much more debated. And
I think if I could, I'd just like to push Duncan's point a little bit. I think Duncan was actually asking not so much about geophysical risk, as it were, as socio-political risk of the sort of discussion actively acting to impede discussion about mitigation. Was that the point you wanted?
The moral hazard argument, I guess, you had in mind, which is that if people were really convinced that there was a quick fix via geoengineering, it would certainly demotivate the efforts to seek an agreement on mitigation. And I think that is a concern, but I don't think anyone is going to be convinced that it is a quick fix.
No, but I think this is as what I did say in my presentation, that is a very strong argument for doing the research.
Yes.
To know what kind of danger we may come, rather than saying, well, if this doesn't work, there is. I agree with what you said, David, about to bring in Plan B as a kind of last resort and Plan B at work. It's not a good way of doing it at all. That's absolutely right. And the reason for doing this right now is to allow a debate. You see, the great thing about human society is that if you actually articulate something, then a debate becomes possible. People say, oh yes, but that could go wrong. And this happens everywhere. The recent attempt by the government of the country of which I'm citizen and proud to be citizen otherwise, to ban a BBC broadcast is also connected with stifling debate on the subject, which until it came up that people could have attitudes of this kind, that may be generally perceived but not publicly discussed. People are afraid of public discussion. That's the thing to recognize. And what I'm suggesting is that they're afraid for understandable reason, because enormous problems can come out only through public discussion, which hasn't happened in the context of Euro and economic policy, India and secularism, and so on. And therefore, arguing for providing as much feed to public discussion, which requires research, which I'm not against at all.
I think a very germane question that actually comes in over Twitter is the question that in public discussion, how, if at all, can one say whose voice matters in that public conversation? Is there a question?
How can one say?
The question that came in, whose voice matters in the public conversation?
Well, that I don't think you're going to get a formula on that. I think the way to do it is to see how many people take. I mean, this is, I think, John Rawls discussed it very well. How many other people find it plausible to pursue that line? If you haven't succeeded in making people persuaded at all, then, I mean, it could still be a serious problem which you just failed to bring out. But I think the more open the public discussion is, less likely it is that these things will go unaddressed, despite the epistemology, the epistemic aspect being clear.
Onora, you wanted to comment on that.
I suspect that there isn't going to be just one public discussion. There's going to be a lot of different public discussions, and also the implications of climate change differ a great deal for different parts of the world. As Amartya pointed out, the Maldives and Bangladesh are in a particularly exposed position for any rise in sea levels. But I suspect there are parts of the world where people are saying, goody, goody, a bit of global warming could really improve our agriculture and our lives. I don't know that, because it wouldn't be a very, I suppose, respectable thing to say, since it implies suffering for others. But I think people who suffer from permafrost a lot of months of the year perhaps rather readily have the fantasy that global warming will be just nice.
There's a question with the yellow microphone.
Thank you. My name's John Taylor. I work for Suffolk County Council in their climate change team. You mentioned two methods of geoengineering, the solar management, but also carbon extraction from the atmosphere. But it seems to me that now we're conscious of the effect of the continued extraction and combustion of fossil fuels, surely we now have to treat that as well as intentional geoengineering. And if we frame that as such, surely that method of geoengineering has been so effective in altering the climate economically because it is a free byproduct of just how we live our lives. And if other means of geoengineering are going to counter it, surely they have to. Are there technologies that exist that they can be an economic byproduct of the way we live our lives rather than being an economic addition to activity?
Does anyone on the panel... Thank you. Does anyone on the panel want to come in on this question? Does it actually make sense to distinguish intentional and unintentional effects on the climate? Are we, to some extent, making a false distinction by calling the burning... I mean, because it's not like we burn fossil fuels by accident, mostly.
Well, it's intentional activity, all right, mostly, but it is not intended as a negative contribution to climate change, whereas I think what we've been talking about this evening are interventions that would be intended as beneficial contributions to climate change. And that's what David was introduced to us.
Perhaps equally important is diffuse versus centralized. So fossil fuels are burned all over the planet, organized, of course, partly by big international corporations, but fundamentally organized by people trying to get energy for their livelihood that have driven the system that we have, that as a byproduct puts all the CO2 in the air. And there's no one person making the decision. It's a highly diffuse process in time and space. Whereas if we did solar geoengineering, the way most of us conceive it, although it doesn't actually have to go this way, is that it's a relatively small group of people who actually do it, whether that's under control of some UN agency or unilaterally. And I think there is something quite distinct about a decision that's kind of involves a small number of people in a discrete activity than a diffuse activity where the climate change is a byproduct.
Another question up there.
Yes. Thank you. David Santillo from the Greenpeace Research Labs in Exeter. I have a question about trust, and it could be for any or all of the panel. If it is the case that research will continue to grow, at some stage, presumably that research will break out from models and become research in the field. And it then becomes very difficult to draw a line. So the question is, who should we trust to set the agenda and to govern that kind of research agenda?
Which of you would like to take that on? Who do you trust to govern the agenda?
I don't think it's probably a good idea to look to one body or person for the standards of research governance. In fact, that's not, of course, how research governance works. Research standardly in this country will go through multiple filters. There will be funding decisions, there will be regulatory and ethical approvals, there will of course be canons of scientific rigor also applied to it. So it's a multiple filter system, and I wouldn't wish to see it integrated so that there was anybody who controlled all the filters.
Question in the front there, and then in fact I'm going to take 3 questions in a row that are going 1, 2, 3 back there.
Turn it on?
Please.
Thomas Brun from the Institute for Advanced Sustainability Studies, and my question mainly goes to you, Professor Sen, because I really sympathize with the relevance of the public debate that you highlighted. But I also see what David brought up about the challenge to learn how to collaborate, how to learn to make decision-making a collaborative process in democracy. And I wonder actually what kind of concrete mechanisms do you see how a public debate could become an integral part of decision-making in democracy beyond just being an important debate?
Okay, I'm going to, no, if you could keep that, move it straight behind you. I'm going to take these three people in a row who've been done that. Yes.
I ask you?
Yes.
Okay. My question is about public debate, how to do it in an efficient way so that it can avoid the problem of bureaucratic inertia that it usually creates.
Okay, and straight behind you.
My question is back to the question of trust, which I think is central, but not trust of individuals, but trust of institutions. In many ways, it was the nuclear power industry lost the trust of people rather than the technology being a complete failure. In the case of climate change, whether we go to renewable energy or whether we have a plan B, we still have to make major decisions, and we don't really have the institutions that have earned the trust to enable those decisions to be made. So my question is, in the process of evolving those institutions, do you have views on the types of initiatives, whether they be economic, whether they be in the public sphere, whether they be in building at different scales, the sorts of processes we need? Do you have any advice on that?
Okay, I think that's a really nice set of questions. I'm aware that we're coming up towards 9 o'clock, so I'm going to take the last question on the yellow mic, and then I'm going to ask the panel, if they could, to bear in mind those questions about how we move from debate to discussion, how we avoid bureaucratic inertia, and how we ensure trust in the institutions. I think these are great topics for us to come back to as we wind up the discussion. There is one more question up on the yellow mic at the top left.
Hello, my name's Ian Simpson. I run a website called look-up.org.uk. I campaign against current and proposed programmes of climate engineering. It's another trust issue, but more in the science, really. If the predictions and modelling that we've heard about today and over the last 10 to 15 years were correct and accurate, we would already be in climate chaos. The ice melting and warming hasn't really occurred, and it's blamed on all sorts of blips and pauses and slowdowns and stuff like that. Yet at the same time we hear, oh, but we've got it wrong for this bit, but don't worry, the predictions are definitely right for the next 20 years, and by 2050 we'll be in climate chaos. On the back of that, people plan to introduce what can only be described as tenuous and extremely dangerous measures that could ruin our climate. So how can we have faith in those modelling systems and science on that basis?
Okay, thank you. So there you have your package for winding up. David, would you like to kick off the wind up as the...
Sure. I guess I'd start by saying I think that democracies in general are having trouble making good decisions about new technologies, given the pace of technological development and the way in which our democracies function. And I think we need to innovate in a way that finds different ways to get some kind of engaged, deep public participation that doesn't take away from the core democratic mechanisms. And I personally am excited by the idea of having things that have different names, but something like a citizens' panels that where randomly selected citizens get to work together for extended time as a group, months, and interact with stakeholders, scientific experts, what have you, calling them at their behest, and then serve it to give non-binding advice to governments. I think that provides a way for citizens to really engage in the issues that is deeper and more sustained in a way that is not very effective in the kind of top level of sort of parliamentary debate and interaction with the press. And I think there's some specific examples where this has been tried, not on climate, but for example, it was tried in developing a voting system in British Columbia, where I think there's some real evidence these things can actually work, and we need this kind of democratic innovation if we're going to make good decisions in a world with these problems.
So that would be a broader process of which you'd want geoengineering to be...
Yeah, I think there's a host of problems, and not even just technical ones, where I think we're not making good decisions as fast as we're having new problems.
Amartya, would you like to?
like to is probably too strong.
Well, no, I could finish the sentence, but I just thought those so like that was something you'd like to do. The issues that were brought up were very specifically the question of trusting in the models, given that there hasn't been much climate change recently, as it appears to some people to be the case. The question of moving from, I think this question that David was just also touching on, this question of moving from debate to decision. And
no, I think I think there's a number of interests. We don't have time to discuss them. The danger of bureaucracy, the danger of inertia, all this came up, and these are serious issues. And we have to go beyond that. And I think the question was raised about collaboration. And I think that's extremely important. But collaboration doesn't take place by just agreeing with each other. Collaboration takes place by having an argument, having a disagreement, and then trying to arrive at some kind of common ground. And I think one shouldn't be so skeptical of our ability. And, David, you even said that democracies are having a major problem, as if non-democracies are not having a problem.
I did not mean that.
But you quoted, David, quite rightly, that you have that you talk with scientists who discuss these issues, and you haven't found one who thinks that it to be a hoax. That's a pretty rare bit of agreement on a subject that's emerged after what? After debate. So I think the idea that somehow if we open up the debate, that's the beginning of the slippery slope. I think we have to get beyond that. And that's why my initial position, which remains still my final position, is that don't trust anyone without a debate. And in the debate, and don't be so skeptical of the debate. And I think the main argument, as I understand it, I remain somewhat skeptical. On the other hand, I've been proved wrong in the past. But I think the very strong argument for doing the detailed experiment about detailed study is to understand what is it that may be the alternative if we can't manage to get there, and if so, what are the dangers of that? That is how the debate proceeds, and that's how collaboration also happens. So I'm comfortable with reconciling emergence of understanding and agreement with debate, and consistently with not trusting anyone without there being a reason to trust that's been established to others.
And can I make a very seconds? And I realize none of us ever said that the total research budget for this solar geoengineering is tiny, at the level of 1,000 times smaller than the normal budget for just the plain climate science. And that's because of the kind of taboo inside the scientific community.
Martin.
Yes, okay. It's quite right that the climate models in detail are very uncertain, and that's why I said I thought it would be 20 years before there was a real consensus and real public motivation. And of course, another point is that I think you need a greater degree of confidence that your model is right before you take action to do something than you do if you are just following a natural trend. That's a problem. But the other problems, of course, are that we need a wide public debate, as we do on any scientific issue that has wide social consequences. But here, it's clear the debate has to be international, because any geoengineering is going to have international impact, if not global impact. So it's got to be international. And there is, of course, a general problem which confronts all debate about climate, which is that politicians in their minds tend to prefer the local over the global, and also the immediate trumps the long term. And in the case of climate, clearly the effects of any action are global, the consequences are worse, and also they are very, very long-term. The worst consequences and the strongest motive for doing something now is, as Amartya said, the small chance of something really catastrophic 100 years from now. And it's very hard to persuade politicians worried about the next election that they should start thinking about what we should do to remove a risk from people 100 years from now.
Onora.
I agree, how could I not, that we need to have debate and discussion, and it needs to be inclusive. But I'm not starry-eyed about what debate and discussion achieve. What they achieve is rather slow and gradual, a sort of ferment that gradually perhaps rules out certain possibilities and makes people feel more warmly towards certain other possibilities. And I am pretty skeptical about the citizens' jury as a format. I think it's absolutely lovely for the citizens who go on the citizens' jury experience, if I may so call it, but that the trickle-down is shown to be rather minimal. So what else to do? And I do think we have to think about institutions as well as particular conversations, discussions, and the rest of it. And my own view is that we have invented some really dysfunctional institutions across the last 30 or 40 years. We've invented a lot of dysfunctional forms of accountability, which, in a sense, have people focused on those to whom they are accountable rather than on the public whom they should be serving. You can see this in many professions, in many bureaucracies. But I'm afraid I'm also skeptical about that very fashionable nostrum transparency. Transparency is all very nice, except that most of us have finite minds and capacities to follow stuff, and what is needed is actual communication, not putting things into the public domain, often with the hope that they won't be much noticed. So I actually think that one of the things that matters, and this is very much a metaphor used in the financial sector, Amartya, and I'm going to call it by its vulgar name, skin in the game. Now, we've all actually got skin in this game, but many of us like to think, oh, it's only people on the coast of Bangladesh or on the Maldives who have skin in the game. No, we all do. And I think that probably what will change the conversation fastest is making people more aware of what skin they have in the game. But it'll also make the debate much sharper because of the people who fancy that they're going to be beneficiaries of global warming. And I don't think we should underestimate how sharp the debate will get. We actually, sitting in this island with its fairly nice climate, may think, oh, won't it be nice when we have all those vineyards on the South Downs? I've heard that said. Well, no, there will be lots of other consequences. So one of the things that all of us can do is to help point out to one another that it may not be nice even for those who are quite seemingly pleasantly situated to benefit. Nobody can predict how this debate will go, but I think we need to have it, and we need the small-scale experimental work, not just in geoengineering.
Well, thank you all very much indeed. And thank you all for being an excellent audience. I'm sure that we can all trust each other now more to go to the pub or whatever else we could take forward the debates. Thank you all very much. Good night.
Thank you for being a good host.